Hi, I'm going to give you an introduction to the DV runtime protocol. This is now supported in the MPLAB data visualizer, but also in the firmware libraries of MCC Melody and coming soon to MPLAB Harmony. What is the problem that the DVRT solves? Well, for general applications, it's quite useful to have a runtime debug communication, even with the smallest microcontrollers. This means the ability to read or write declared firmware variables without having to change code, recompile or reprogram. And it should be light and small. Light in terms of protocol and small in terms of flash or RAM, so it doesn't impact too much your own application. Let's have a look and see how this can be the equivalent of adding a watch in breakpoint debugging, but now with the ability to graph the state of these variables at runtime. So in my project I have a variable LED on. I can right click, add it to a watch, and then when I use a breakpoint, it's off because it hasn't been updated yet. I step over and it is keeping the state of my LED variable, and the value of these variables is updated every time the program is halted. And you can see how the project and these variables change and behave, but only when you hit a breakpoint. So it's a static analysis. What happens with the DV runtime is that these variables are added to a streaming table, and then this table is updated live. And so this allows you to view and also modify the value of these variables as the application is running. Let's have a look at the first use case from the MCC Melody API reference. We can start modifying some of the variables. So, for example, taking the process calls and resetting that to 0. Immediately you can see that the variable updates. And we can, for example, also change the period of the LED to a second. Immediately the LED updates. Now clicking on the DVRT protocol, we can see that we can change a streaming tick, making it 20 milliseconds, and immediately the smoothness of the plots are increased because we are sending frames much more frequently. So let's have a look at a use case which really can show off some of the capabilities of the DV runtime. So I'm going to use a PIC18F Q41, which happens to have an ADCC, which is an ADC with computation. Now, we have the ability to set up the ADC to generate an interrupt when the rate of change of ADC samples against an average or against the last reading exceeds a certain threshold. So what to focus on here is just the way that we're able to kind of tune this application using the DVRT. And there is another video linked below where you will be able to build up this application from scratch using the data streamer protocol, but hopefully you'll be able to also modify it to use the DVRT. Let's have a look. So if we're going to start a DVRT session, we must be sure to uncheck our breakpoint, start our application running. Note that some of the ADC results and the result of the last spike are at the top here, and these are what I'm going to plot. So opening the data visualizer, go to a DVRT session, and on the COM port select 115/200 and load debug symbols, distribution, default, debug, and the debug.elf. If we open and push play here on the data visualizer, no news is good news here, and we get this running. So we wanted to look at the ADCC result and the ADCC result last spike, and we can see values there which change as I move my pot, and we can also now plot all these variables. Now because these are both UN16, they come up on the same plot as we see there. Now we can also use some of the more traditional things like debug IO. So I'm going to add a plot. This is the active plot, and so when I add debug IO, you can see it comes up there. Now this is going to be toggling every time we get a spike. So before we can go on, it's good to understand a little bit about what this feature is that we're actually looking at. So I'm going to go to MCC and have a look at the ADCC. Let's scroll down and look for something to do with threshold settings. There's an upper and lower configuration setting here, and we can see 100 and 35 as the values. Let's go into main, scroll down, click on system initialize, go to the ADCC and find 35. This is the register where we're setting that sensitivity. So in the DVRT we can search for this register, and so just looking at the performance now, we haven't changed anything yet, but this is when going up. So if we change this to say 100, you can see immediately as we're going up we are losing. If I go really quickly, they stick together, and going slowly they don't. And we can do the opposite extreme here, say 2, where even if we go really slowly they follow each other really well. And there we go. So yeah, we've been able to add and change values and even update registers live while running our project. And it's an exciting new protocol, and have fun playing with it.